this is lesson on trig ratios part 2 on solving right triangles. So to solve a right triangle means to find all side lengths and angles of a triangle. So far we have discussed multiple ways to find the side lengths of a triangle. So we've learned Pythagorean theorem, a squared plus b squared equals c squared. We've done trig ratios. And then there's also this thing called inverse cosine, inverse sine, and inverse tangent that lets you find the angle measure if you know the trig ratio. So an inverse operation is like if you square something and then if you square root something, or like adding and subtracting, or multiplying and dividing. Those are all inverse operations. So taking the sine of an angle and then gives you a ratio. But then if you take the sine inverse of the ratio, you get an angle measure in degrees. So that's what we're going to learn how to do today. So we'll skip that part. So inverse trig operations are sine inverse, cosine inverse, and tangent inverse. They're used to find the angle given the ratio of the sides. So if you know the sides but you don't know the angles, you can use this. To find angle measures from the trig ratio values, so these are the buttons on the calculator, so you just press second and then sine, cosine, or tangent button. So for here, if you have the sine of A equals 3/5, you would take the sine inverse of 3/5, which is also 0.6, in your calculator, and that should give you the angle measure. So if I do second sine 0.6, then the angle A is 36.9 degrees. Here, if I know that the tangent of B is 0.5774, then to get angle B, the measure of angle B, I do the tangent inverse of 0.5774. And we get 29.1 degrees. Oh, I think I typed that in wrong. Two sevens. 30. So this is about 30 degrees. Okay, so you get the point. So you do cosine inverse of 1/2 and then sine inverse of 2/3, and I'll let you do those ones on your own. Okay, so here it says to use a calculator to approximate the measure of A and C. So first we're going to need to set up a trig ratio based on which side lengths we know. So let's just take a look at angle C here. We know the opposite side and the adjacent side. So then we could use, if we don't know the hypotenuse, then we would use tangent. So we'll do the tangent of C equals opposite over adjacent. So that you can simplify if you want. So you can cancel out the zeros, so that'd just be 2/3. So to solve for C, you would do the tangent inverse of 2/3. So let's type that into our calculator. Tangent inverse of 2/3 equals 33.7 degrees. All right, and then if we want to find B, so that's angle C. To find angle B, well, B is already 90. So to find angle A, we would subtract C from 90 because the measures of an angle or measure of a triangle add up to 180. So if you already know that the right angle is 90, then you have 90 left over. So these are called what we call complementary. So they add up to 90 degrees, A and C. So to figure out A, you would just take 90 minus 33.7, which you could probably do in your head. I'm just going to do 90 minus the answer. So 56.3 is angle A. Okay, let's do number 6. So here, let's look at from angle A. So we have opposite over hypotenuse. Remember SOHCAHTOA, that would be sine. So we'll do the sine of A equals 14 over 26, and then do the sine inverse of 14 over 26, and that'll give you the measure of angle A. So 32.6. And then to get angle C, that's angle A. So C will be 90 minus that, minus 32.6. So 57.4. So those are our answers. Okay, and then this one, let's look from angle A again. So we know the adjacent side and we know the hypotenuse, so that would be cosine. So cosine of A equals 9 over 22, and then do the inverse. Cosine inverse of 9 over 22. Maybe I didn't explain this well enough, that this -1 symbol, that means inverse. So we don't say sine to the -1, we say sine inverse. So that gives us A is, what, let's do cosine inverse 9 over 22 is 65.9. So that means that angle C is 90 minus that, so 24.1. Yeah, 24.1. Okay, could I have done angle C and then done opposite over hypotenuse? Yes, I could have used sine for angle C. So there's multiple ways that you can go about doing these questions. Let's go ahead and do a couple on here. So where you're solving for the entire right triangle. And then it says give exact answers where appropriate, round decimal answers to the nearest tenth. Okay, so the first thing I might want to do is look to see if you can solve side lengths. So if I know this side and this side, I can use Pythagorean theorem to get Pn, because that's the hypotenuse. So I'm going to do 12 squared plus 17 squared equals c squared. And then really I'm just taking the square root of all of that. So I'm going to take the square root of 144 plus 17 squared, I don't know what that is, 20.8. So this side gives us 20.8. Okay, and then we don't have either P or N, so we're going to have to set up a trig ratio and then use the inverse of that to get the angle measure. So if you don't have an angle measure, then you would use an inverse trig ratio. So let's just base off of the side lengths that we had. So if I look from angle P, we were given the opposite and the adjacent side. So then I would use the tangent. So the tangent of P would be 17 over 12. So we're going to do the tangent inverse of 17 over 12. Tangent inverse 17 over 12. And that gives us 54.8 for angle P. And then angle N would be 90 minus that. So 35.2. Okay, and then we've solved for the triangle. So there's always going to be 3 things that you'll need to solve for. Okay, let's try an example like number 9, where you're only given one side length, but you are given an angle. This one's easier because, well, easier in a way. To get angle V, we just have to get 90 minus 50, which is 40 degrees. So V is 40 degrees, and then we need to get one of these sides. So I'm going to go ahead and get MD. So if I want to get MD, that would be the adjacent side to angle 50. So I have adjacent and I have opposite. So we would use the tangent. So the tangent of 50 equals, I'll say x over 21. And then this is one where we multiply both sides by 21. So we have 21 tangent of 50 equals x. And then go ahead and type that in your calculator, 21 tangent of 50. So that gives us 25.0. And then we would use, you could use Pythagorean theorem from there to get the hypotenuse. We would do 25 squared plus 21 squared, take the square root of that. (21 squared plus 25 squared gives us 32.6. So that gives us VD. And then this was MD. And then 40 degrees. So 3 things that you need to solve for. Okay, so I will save the other examples for another edge elastic, or just put them in your, just put them in your next edge elastic. Okay, so that's all. Hope you guys have a great day.